Continuing our work with the cross product, we're going to find a non-zero vector orthogonal to the plane through points P, Q, and R, and then the area of the triangle PQR, where P is the point 0, 0, negative 3, Q is the point 4, 2, 0, and R is 3, 3, 1. I think a visual is in order. Now, the visual is not necessary in this case, but it'll help you to see what we're trying to do here. First, we have here the points P, 0, 0, negative 3. Q is the point 4, 2, 0, and R is the point 3, 3, 1. And what you're looking at here in this bluish color is the actual plane, right? The gray one is the XY plane. And I used GeoGebra 3D. There's a link on my website or in modules. And the red axis has an arrow pointing, kind of towards the right. But the back side of that axis doesn't have an arrow. The green axis has an arrow pointing very much to the right. And then the blue axis is pointing up. That gives me the orientation, and it tells me that the red axis is the x-axis, the green is the y, and the blue is the z-axis pointing up. So what we're looking at here with these axes is really it's a rotation of the way we typically view R3. Now that that's out of the way, what we're after is a vector that is orthogonal to the plane. So it should meet the plane at a right angle. And that's a tall order if we don't have vectors, but we do. And in particular, if we form a vector PQ, and then also form a vector PR, those vectors both exist in the plane that we're talking about. And if we find the cross product of those vectors, then what we're going to end up with is something that is orthogonal to both of these vectors, and therefore is orthogonal to the plane. So the vector that we're after is actually going to be PQ cross PR. With that in mind, I'd like you to go ahead and find that cross product. Pause the video, come back when you're done. Now I'm going to get to it, the work in a minute, but I did leave out something very important here. It's really minor, but very important. When I drew the vector PR, I didn't put an arrow on it. Without the arrow, it's not a vector. So please don't go back and rewind and double check that I didn't do it. It's here now, and that's all we care about, right? Anyway, folks, if we're going to take PQ and PR and cross them, we have to have them as vectors. Here we have points, PQ and R. And so we needed to form the vector PQ by subtracting coordinates of Q minus coordinates of P. Remember, it is terminal point minus initial point. So PQ has components, the vector PQ has components 4, 2, 3, and PR has components 3, 3, 4. If you got stuck there, then please repause the video and get to the rest of it, of the work, and then come back. If you didn't get stuck, then just keep watching, and I'm going to scroll. Here it is. Okay, so the cross product, PQ cross PR, results in 8 minus 9i minus the quantity of 16 minus 9j plus 12 minus 6k. So we have the vector -1, -7, 6, which is orthogonal to the given plane, and we see that here. It's the blue vector formed by the cross product. Using the right-hand rule, we crossed PQ with PR, and so this vector points up here toward the left. If you had decided to reverse the order, you would still have a vector that is orthogonal to the plane. It would just be pointing in the opposite direction. And so 1, 7, -6 works just as well. Folks, you could have used 2, 14, -12, or for that matter, 1 over pi, 7 over pi, -6 over pi. Any scalar multiple of the cross product will give us a vector that's orthogonal. I'll box the answer here that I have. The second one that I gave you, 1, 7, -6. Now for part B. Part B asked us to find the area of the triangle PQR. For that, we need the magnitude of PQ cross PR. So this here was the answer to part A. Now, for part B here, the magnitude of PQ cross PR is equal to the square root of 1 plus 49 plus 36, which is equal to the square root of 86. The area of the triangle is half of that. Remember that the magnitude of the cross product gives me the area of the parallelogram, and a triangle is half of a parallelogram. See, here I have a parallelogram, and half of it is a triangle. So the area of the triangle is the square root of 86 divided by 2. Now, folks, for the area of the triangle, the magnitude of the cross product, I had to use 1, 7, negative 6 or negative 1, negative 7, 6. I couldn't have used the 2, 14, negative 12 vector because that's not PQ cross PR. They have the same direction, but it's not the same vector. So I have to use the cross product itself in order to compute something like the area of a triangle. I'm going to move this over here and then circle the final answer there. There we are.